Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today we continue our lecture on chapter 4, which is integration by parts. Okay, so for today lecture, it is involved integration by parts and also the alternative in order to solve using integration by parts. We call it as tabular methods. And then we try to solve a little bit exercise based on the integration by part questions. Okay, let's go through what is the integration by part. Integration by part was introduced when it is impossible to solve by using a substitution technique. As we know, last week we already learned how to solve the integrations by using substitution method. But somehow, not all the questions or all the problems involve integration we can solve using substitution technique. So we can try to solve the other way, which is integration by parts. Okay, usually the idea of integration by parts is from a product rule. If we have integration u times u with respect to dv, then the integration by part is uv minus integration v du. So in this case, you have u dv, but you need to find first what is v and then what is du. So if from this questions, which is you have u and dv, so from u we can find du, and then from dv we can find v. In order to find du, we directly differentiate. Okay, so when we differentiate u, we can get du. Okay, and then if we did integrate dv, therefore we can get v. Okay, so this is the way to solve the integration by parts. Now looks on the example. Okay, example 7. Evaluate the integrations of x square ln x dx. So when we have x square ln x dx, from this case we need to find what is u, okay, what is dv. Okay, so for this case, u equal to ln x, and then since we take u equal to ln x here, so dv automatically becomes x square dx. Okay, so from here you must differentiate, so you can get du dx equal to 1 over x. Okay, and then this one we need to integrate. Okay, integrate dv, you can get v equal to, and then integrate x square with respect to dx, you can get x cubed over 3. So now we already have u, and then we already have v, and then du here equal to 1 over x dx. So in this case, we want to substitute with the x. So maybe we can modify that one, becomes du equal to 1 over x dx. Okay, so we can solve these problems. We can get the integrations of x square ln x dx equal to uv minus integrations of v du. So this one equal to Okay, what is your u? U equal to ln x. And then what is your v? V equal to x cube over 3 minus integration of v. Okay, your v equal to x cube over 3 and your du equal to 1 over x dx. So we need to solve on this part, okay, because it is still have symbol integrations. So from here we can get x cube ln x over 3 minus, simplify that one first, you can get x square over 3 dx. Okay, so integrate this part. Okay, so you can get x cube ln x over 3 minus x cube over 9. 9 come from 3 times 3 and then plus c because it is infinite. Okay, so that is the answer for example 7. Okay, now looks on the example 8. We want to evaluate the integrations of exponent x cos x dx. So in this case, we choose u equal to exponent x. Of course, dv equal to cos x dx. Okay, so you differentiate du dx equal to exponent x. Therefore, du equal to exponent x dx. And this one, we need to integrate here. We can get v equal to integrate cos x equal to sine x. Now, we can put in the formula, which is the integrations of exponent x. Okay, cos x dx equal to uv minus integration of v du. So what is your uv? Uv equal to exponent x, v equal to sine x minus integration of v du. Your v equal to sine x, du equal to exponent x sine x dx. But if we look here, it still involve product between two functions, which is exponent x sine x. So we need to solve this part one more time. Okay, so this one we can choose u equal to exponent x and then dv equal to sine x dx. Okay, this one solve for this one. Okay, in the red line here. Okay, so du dx equal to exponent x. Therefore, du equal to exponent x dx. So this one we need to integrate here so we can get v. So integrate sine, you can get negative cos x. Please do not confuse between integrate and differentiate. Okay, so from here we can get the integration of exponent x cos x dx. So this one, for this one, equal to exponent x sine x, just copy direct, minus solving for this part, must put in the bracket here. Also, same thing, we apply uv minus integrations of v du. Okay, So transform to here, we can get uv. Okay, u equal to exponent x, v equal to negative cos x, okay, and then minus integrations of v du, okay, negative cos x du equal to exponent x dx. Okay, so puts in the bracket. When we solve this one, expand, so we can get simplify on the right hand side, open the bracket here, we can get exponent x sine x, minus minus become plus exponent x cos x, and then minus minus plus minus here, because this one is minus minus and minus, so it's become minus here. So integration of exponent x cos x dx. Okay, if we can see this one is equal to this one, so we can move, okay, to the left hand side, so we can get 2, because here is negative. When go to the right hand side, it is become positive, positive positive, so it is become 2 exponent x cos x dx equal to exponent x sine x plus exponent x cos x. Okay, and then we want to find only integrations of exponent x cos dx. So integration of exponent x cos x dx equal to, here is 2, it's become 1 over 2 when we move to the right hand side, and then times by, must put in the brackets, exponent x sine x plus exponent x cos x plus c. So that is the answer for example 8. Okay, okay, next, integration by part using a tabular method. So this one is the one of the alternative in order to solve the integration by part using a tabular method. Okay, what is tabular method? Okay, so we can solve the integration by part using a tabular method, also same thing here, but we are try to choosing the value of u, okay, by follow these terms, which is LOPET. LO stand for logarithm. If in your problems involve logarithm, you must choose u start with logarithm. Okay, if you don't have logarithm, you looks on the second level, which is polynomial. If your function involve polynomial, so you must choose u as a polynomial. And then if you don't have polynomial, next we can choose exponential. And then the last one, we can choose a trigonometry as u. Okay, because you need to choose what is your u, what is your dv. Okay, the value of u you want to differentiate, and then value of dv you want to integrate. So you must choose which you must put as a u in the tabular method. Okay, so looks on the example 9. Okay, we have integrations of 4x exponent x. So by using LOPET. Okay, so in these forms, you have 4x and exponent x. So which one is u? Looks the priority logarithmic. you don't have logarithmic here, so you cannot choose. Next, polynomial. Yes, you have polynomial, which is 4x. Okay, so therefore, this 4x as a u, and then exponent x dx as a dv. Okay, so next, you must draw a table in order to solve this one. Okay, which is the sign. Okay, and then differentiation is a value of u, and then the third one is integration is a value of dv. You need to integrate. So in this case, your u equal to 4x, and then your integration is exponent x. So you differentiate for u until you get 0. After you differentiate for x, you can get 4, and then after you differentiate 4, you get 0. So you stop there. Integrate exponent x, also you can get exponent x. Integrate exponent x, also you get exponent x. So here you must integrate. Okay, and this one you must differentiate. Okay, and then here, what is your sign? First, we start with plus. Second, we start with negative. And then third one, we start with plus. Okay, now looks on the arrow. Here you must times, and then this one you must times here. Okay, so the solutions of your integration between 4x exponent x dx equal to 4x times by exponent x, and then it is plus. Okay, doesn't matter that one, so it's become 4x exponent x, and then minus 4 times exponent x, because this one you must times. Okay, multiplication. So minus, why it's minus? It's referred to this one. Okay, so 4 times exponent x, you can get 4 exponent x, and then plus c. So that is your answer for example 9. Okay, by using tabular method is more easiest lah. Okay, next, example 10. Example 10 evaluates the integrations of ln x divided by x cubed dx. So in this case, remember, you have ln x and 1 over x cubed. Remember, this one is a product, so you must choose which one is u by using formula Lopez. So, okay, formula Lopez, logarithmic, polynomial, exponential, and trigonometric. So this one you have ln, so this one is your u. Okay, and then this one is your dv, so automatically you have dx here. So for the first one, okay, you must write a table, okay, which is first sign, then you must differentiate value of u, and then integrate dv here. So your u is ln x, your dv equal to 1 over x cubed. Okay, so you differentiate ln x, you can get 1 over x, and then differentiate one more time, you can get negative 1 over x2, and then since this one you cannot get 0, so we integrate the last one 2 over x cube. Okay, so this one we can get for integrations negative 1 over 2x squared, and then 1 over 2x. Ingat this one is integration, and then integrate 1 over 2x, you can get 1 over 2 ln x. So this one, the symbol is plus minus plus minus. Okay, since you cannot get 0 here, you must do until 4 times. Okay, so here we multiplication between this value and this one, multiplication this one, and then since you cannot get 0, so the last one you must integrate with this one. So this one is integration. Okay, so from here we can get the integrations of ln x cube dx. You can get ln x times by negative 1 over 2 here. So this one you can get negative ln x over 2x squared minus, since here is minus, okay, so you can get negative 1 over 2x squared, and then minus ln x over 2x squared, and then the last one, since the arrow is here, okay, so this one you must minus with, because here is minus, integrations of ln x over x cube dx. Okay, if we can see, this one is equal with the left hand side, so we move this part to the left hand side. Therefore you can get 2 integrations of ln x over x squared dx equal to the rest you can get negative ln x over x squared. Okay, because this one you can solve with this part, so it's become negative ln x divided by x squared minus 1 over 2x squared. Okay, but we don't need the value of 2 here, so we move to the right hand side. Therefore it is become integrations of ln x over x squared dx equal to, so it's become 1 over 2 in the bracket negative ln x over x squared minus 1 over 2x squared plus c. So that is the answer for example 10. Okay, okay, now looks on the exercise. We have a 3 exercise here, which is exercise 8, exercise 9, and exercise 10. Let's move one by one. Exercise 8. Okay, evaluate the integrations of exponent x sine x dx. Okay, so this one we let u equal to exponent x, and then of course dv become a sine x dx. Okay, so we differentiate u du dx equal to exponent x, modify du as object, it's become exponent x dx, and then this one we need to integrate dv, we can get v equal to integrate sine x negative cos x. Okay, Okay, now put in the formula, which is integrations of exponent x sine x dx equal to uv minus integration v du. So we can get your u equal to exponent x, your v equal to negative cos x, so become negative exponent x cos x. Okay, and then minus integrations of v is negative here, so it's become plus. Okay, so exponent x cos x dx. So if we can see here, this one still involve product of two functions, so we need to solve one more time here, which is u equal to exponent x dv equal to cos x. So du dx equal to exponent x, du equal to exponent x dx. And then this one we need to integrate, so we can get v equal to sine x. So we can solve this part, which is exponent x sine x dx. Just take from here, equal to negative exponent x cos x plus, must put in the bracket here, so you can get exponent x sine x. This one come from uv minus integration v du, but you must choose from this part. Okay, so your u equal to exponent x, your v equal to sine x. That's why we got exponent x sine x minus integrations of your v equal to sine x, your du equal to exponent x sine x. So I put as exponent x sine x dx. Okay, if we can see here, also same things by the previous example, we got the same thing as value. So move to the left hand side, we can get 2 integration of exponent x sine x dx equal to exponent x negative exponent x cos x plus exponent x sine x. But we want to find only for integrations of exponent x sine x dx, so we don't need the value of u. So we transform value of u to the right hand side, so we can get integrations of exponent x sine x dx equal to 1 over 2, and then put in the bracket here, negative exponent x cos x plus exponent x sine x, and then plus c. So that is the answer for exercise 8. Now looks on the exercise 9. You want to evaluate 3 integrations of a 3 ln square root dx. So we can choose u equal to ln square root of x. So your dv equal to 3x dx. So your du dx equal to 1 over 2 ln x. Okay, and then your du equal to 1 over 2 ln x dx. And then this one you can integrate to get v equal to 1 over 2 dv equal to 3x squared over 2. Okay, so puts in the formula integrations of 3x ln x dx equal to uv minus integrations of v du. So your u equal to ln square root x, your v equal to 3x squared over 2 minus the integration of v, okay, 3x squared over 2 times by your du equal to 1 over 2 ln x dx. Okay, sorry, this one is not ln over x. Sorry, this part, sorry for this part. This part we simplify as u, okay, because here we have u equal to ln x the power of 1 over 2. When we simplify this one, we can get u equal to 1 over 2 ln x. So when we differentiate du dx, so we can get 1 over 2x. So du equal to 1 over 2x dx. So here supposedly we have 1 over 2x, okay, dx. Okay, so this one we can simplify. Okay, so you can integrate this part, ln x times by 3x squared over 2. Okay, so that one in minus integration of simplify first, you can get 3x over 4 dx. So we can integrate ln x 3x squared over 2 minus 3x squared over 8. Okay, and then plus c. So that is the answer for the exercise 9. Okay, so this one is not correct. So just refer to the right hand side here. Okay, now proceed to the exercise 10. By using tabular method, evaluate the integration of x cos 2x. So you have between these two functions, which is x and cos 2x, by using L'Hopital. Want to choose value of u. So x is the polynomial, so this one is a u. Cos x is trigo, so you cannot choose. So this one puts in the table here, which is sin, differentiate the value of u, and then integrate with value of dv. So your u equal to x, your integration dv equal to cos 2x. Okay, differentiate x, you can get 1. Differentiate 1, you can get 0. So you stop until there. Cos 2x, integrate cos 2x, you can get 1 over 2 sine 2x. Integrate 1 over 2 sine 2x, you can get negative 1 over 4 cos 2x. Plus minus plus is the sign here. Okay, so this one is a multiplications and this one is a multiplications. So we can get the answer of integrations of x cos 2x dx by using tabular method, which is x times by 1 over 2 sine 2x. So you can get x over 2 sine 2x minus here, but here is also minus, so it's become plus 1 over 4 across 2x plus c. Okay, so that is the answer for exercise 10. Okay, thank you, that's all.